Today's lesson was on linear programming, so we want to make sure that when we do the homework tonight that we're comfortable seeing how linear programming works. We're going to have several constraints on a situation, and we're going to be able to figure out what maximizes or minimizes a third value. Now we're going to look at two problems. The first one, page 163, number 3. And let's see here. It says, your mathematics club has arranged to earn some extra money by cleaning up the car park. The city recreation department agrees to pay each old member $10 and each new member $8 for their services. The club did the same thing last year, so the old members are experienced. To find variables, then write an equation expressing the dollars the club earns in terms of numbers of old and new members who work. Well, we don't know the number of old members or the number of new members, so we're going to make n equal the number of new members. And we're going to make, I don't like making O a variable ever, so we're going to make D the number of old members. And we don't know our amount of money either. We do know that since we get $8 for each new member, that we have 8n plus 10d, $10 per old member, equals our amount of money. So we defined those variables, and it gives us the following facts that restrict the number of students who can work. Well, a lot of these, some of these we might already know. For example, the number of old members is non-negative, and so is the number of new members. Well, that would tell us that our number of new members is greater than or equal to 0, and our number of old members has to be greater than or equal to our number of old members. Oh, sorry. Our number of old members also needs to be greater than or equal to 0. Then the club has at most 9 old members and at most 8 new members who can work. So we know that number of new members is less than or equal to 8. Number of old members is less than or equal to 10. The department will hire at least 6 students, but no more than 15. Well, we don't know what mix of students we're going to have, but we know the total means the number of new plus the number of old. So we can go ahead and the number of new plus the number of old is between 15, and on the small end, the smallest it can be was 9. Oh, sorry, 6. Then, the new restriction is that there must be at least 3 new members. So, I'm tempted to just scribble this out and write it as a 3. I would accept that for you, but we'll also say that our number of new members is greater than or equal to 3. And then it also has that the number of new members must be at least 1/2 the number of old members, but less than 3 times the number of old members. So a lot of equations here. So we have the number of new members, n, must be at least 1/2 of the old members. So we know we're comparing the number of new members to 1/2 of the number of old members. It must be at least. So that means that it could be more, or it could be equal to. It also says that the number of new members must be less than 3 times the number of old members. So the number of new members must be less than 3 times the number of old members. These are a lot of restrictions, and we're going to have to go ahead and draw it so that we can get some accuracy for possibilities. So let's make a graph of this. We're going to make the vertical axes be the number of old members. And we're going to make the horizontal axes the number of new members. Okay, so we have to go ahead and we have to plot these things. We know that our number of new members has to be greater than 3 and less than 8. If you went ahead from the very beginning and said, hey, that has to be bigger than 0, 2, that's not a problem for the number of new members, and saying the number of old members had to be greater than 0, that's not a problem. But we also have that the maximum we can have is 10 old members. So let's go ahead and let's put some coordinates here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 up here. We're going to have to have less than or equal to that. Then we also know that our number of new members has to be less than or equal to 8. So, sorry, that's not a great line. We also know that the number of new members is greater than or equal to 3. So we know we're working at this point inside this box. Well, we have some additional information. The total number is greater than 6. So what we're going to do is graph the line n plus d equals 6. That has a new member intercept of 6 and an old member intercept of 6. 1, 2, 3, 4, 5, 6. So this is where our new old is written with the new as the independent and the d as the dependent. In reality, these are interchangeable, so your graph could look different. So we have this right here. This is the line where the number of new plus the number of old is 6. We could go ahead and plug in here 0, 0 and find out that 0, 0 wouldn't work for this. So we can go ahead and shade away from it. So we're shading in this direction. Then we also have that the number of new plus the number of old has to be less than or equal to 15. So that gives us two values. The two values are going to be 15, 0, 15, 1, 2, 3, 4, and this fifth one is 15. And then down here, 9, 10, 11, 12, 13, 14, 15. Now it's sometimes hard to make sure the scale is exactly right on these, but we could go ahead and consider some other points that are maybe closer that gives us the number of new plus the number of old being 15. For example, 8, 7, 6, 7. That's going to have to be on our graph. And then let's see here, 10, 5 will also have to be on our graph. And it's going to be a little off scale here because this scale is a little more spaced out than it is up there. All right. Now we know the number of new plus the number of old has to be less than 15. Be a spot where 0, 0 is true. So we're shading in this direction here. We also have the number of new is less than 3 times the number of old. Let's see a few values that would work for creating that equation. 0, 0 would definitely work. The number of new is less than 3 times the number of old, so if the number of old was 1,